Boyles Gas Law. In this video, we're going to take a look at a Boyles Gas Law problem. I'm telling you that in this example, but you won't always get that information, perhaps on a quiz or on a test. So I'm going to show you how to figure out, first of all, that it is Boyles Gas Law and which equation to use, and then how to solve it. So let's dive on in here. As I read this problem, I like to box in my variables and just kind of label them as I go, and that way it'll kind of expose the right gas law I need to use. So it says a 6-liter container. 6 liters, I know that's going to be volume because liters is always a unit for volume. I'm going to label that as volume 1. The container of nitrogen has a pressure of 5.3 atmospheres. There's my pressure 1. Clearly says atmospheres is a unit of pressure. What volume, we are looking for volume 2, that's going to be my unknown, so I'm going to use a green question mark by it, would be necessary to decrease the pressure down to, here's my final pressure, here's my pressure 2, down to 2 atmospheres of pressure. Okay, perfect. So I've labeled all my variables. As I look at my variables here, I only see pressure and volume. This question says nothing about temperature, so we can assume it's held constant. It also says nothing about moles, so I know I'm not going to be using the ideal gas law. So what I like to do is write out the entire combined gas law just as is, and then you can cover over your constant variable, and just like magic, you will see the correct equation appear. So in this case, if I cover over my constant variable of temperature, again, I know it's constant because it didn't mention anything to me about temperature in the problem, I will magically see Boyles Gas Law appear right before my eyes. And remember, Boyles Gas Law is the only one that has an indirect relationship, and it states that if pressure goes up, volume goes down, or vice versa. So from here, it's just a simple kind of plug and chug situation. What did I label as my pressure 1? Well, I can plug in 5.3 atmospheres. My volume 1 we said was 6 liters. My pressure 2 we said was 2 atmospheres. And my volume 2 is unknown. So from here, it takes a little bit of algebra, which I know some of my students hate, some algebra and rearranging this equation to get my unknown variable isolated. To get V2 all on its own, I'm going to have to divide both sides by 2 atmospheres. That way it'll cancel out on the right and give me just V2 on that side of the equation. So to solve this, you should punch in your calculator 5.3 times 6 divided by 2, and you should end up with, for a final answer, volume 2 equals about 15.9 liters, depending on how you round there. So there's my final answer. Another quick way that you can kind of check your answer is to really think about Boyles Gas Law and the relationship there, that inverse relationship. Look at your pressure. My pressure started at 5.3 and it ended at 2. So my pressure went down. According to Boyles Gas Law, we know that volume should go up. So let's compare our two volumes. We started at 6 liters, we ended at 15.9. Did my volume go up? Well, yeah, you probably solved the equation correctly. So there are kind of built-in checks there. You can use the relationship of Boyles' law to see if you're getting a correct value. This has been a Rodriguez original production. Hope you enjoyed it. Practice, study, do more examples. Good luck.